Hey everybody! In this video, we're going to be talking about finding equations of tangent lines. The big question is, how do you find the equation of a tangent line at a point on a function? Recall that a tangent line is a line that touches a curve at one point and is locally linear at that point, meaning it matches the curve's slope at that point. In order to write equations of tangent lines, there are three simple steps that you have to follow. First, find f prime of x, the derivative of the function. Second, find f prime of c, where c is the x value of the specific point in question on the function. And third, use the point-slope form of a line to write the equation of the tangent line using the information that you've found. Let's look at a series of examples. Suppose we need to find the equation of the tangent line at x equals 1 on the function f of x equals x cubed plus 2x squared plus 1. The first thing we should note is that c equals 1. That's the specific x value in question. So let's follow the three steps. First, let's find f prime of x. In this case, f prime of x equals 3x squared plus 4x. Next, let's find f prime of c, in other words, f prime of 1. F prime of 1 equals 7. And then, let's use the point-slope form of a line to write the equation of the tangent line. Y minus f of 1 equals f prime of 1 times x minus 1. We can substitute f of 1 and f prime of 1 into this equation, and this gives us y minus 4 equals 7 times x minus 1. That's it. That's the equation of the tangent line at x equals 1. We're done. Let's look at another example. Find the equation of the tangent line at x equals pi on the function f of x equals sine 3x. Let's follow the steps. First, we're going to find f prime of x. In this case, f prime of x equals 3 cosine 3x. Note that we have to use the chain rule. Then we're going to find f prime of pi. In this case, f prime of pi equals -3. Then we're going to use the point-slope form of a line to write the equation of the tangent line. Y minus f of pi equals f prime of pi times x minus pi. Then let's substitute in the values for f of pi and f prime of pi. F of pi equals 0 and f prime of pi equals -3. So this gives us y minus 0 equals -3 times x minus pi. That's the equation of the tangent line. Sometimes you may come across interesting cases when trying to find equations of tangent lines. Here's an example. Find the equation of the tangent line at x equals 1 for f of x equals 2 plus the quantity of x minus 1 to the 1/3 power. So let's follow the steps. F prime of x equals 1/3 times the quantity of x minus 1 to the -2/3 power. That's the same thing as 1/3 times the quantity of x minus 1 to the 2/3 power. But notice that f prime of 1 is undefined because the denominator is 0 when 1 is plugged in. However, the function is continuous at x equals 1 because f of 1 equals 2. So what's going on here with this function? Well, here's a graph of the function. Notice at x equals 1, there's a vertical tangent. Since we have a vertical tangent line, we can't use the point-slope form to write the equation of the tangent line. So in this case, the equation of the vertical tangent line is x equals 1. Okay, here's one more example to consider. Find the equation of the tangent line at x equals 0 on the function f of x equals the absolute value of x. Well, this is an interesting case because at x equals 0, the absolute value of x has a corner point. But remember, functions are not differentiable at corner points, so the derivative doesn't exist at x equals 0. And as it turns out, you can't find the equation of a tangent line at a corner point on a function. So this particular question has no solution. Even though a line can be placed so that it touches a corner at only one point, it will never be locally linear to the function. Therefore, tangent lines do not exist at corners on functions. So in summary, to find the equation of a tangent line, you need to first find f prime of x, then find f prime of c, where c is the specific x value in question. Then use the point-slope form of a line to write the equation of the tangent line. But just be aware of certain cases where tangent lines might be vertical or where they might not exist. Tangent lines will never exist at holes, corner points, asymptotes, or endpoints on functions. Writing equations of tangent lines is a crucial concept in calculus, so just keep on practicing. And that's how you rock calculus!